maybe some statisticians are very good. Ari Fisher was great at genetics, for example. Tukey knew a lot of chemical engineering. I took some of his classes. So there's a lot of very smart people who know a lot of other things outside of statistics. But these are separate questions. And so when Einstein was considering the thought process of special or general relativity, he wasn't running a randomized controlled trial, even hypothetically. He was talking about imagining different thought process, imagining this happens and that happens, and what would happen if these two went together. That's that's what scientific creation is about. So.
We have another question. You mentioned the chain rule, which is a derivation mathematics rule. Is this what Wright's path analytic method rested on, the effect of x on distal y being the product of all path coefficients along the way?
Essentially, you can recast that. I mean, he was dealing with linear equations, and therefore the Wright method you could use by substitution. For example, there's a great book by Arthur Goldberger with Klein years ago. It's called Impact Multipliers. And so they estimated an econometric model, a Keynesian model of the economy that Klein helped develop, and Klein and Goldberger did. And they were looking at what the impact was of investment expenditure on future income, future national income. And so what they did is they traced, today you make an investment, that investment actually then gives you a forward, it allows you to go forward and looks at how that raises income. Now, what does that raised income do? It makes people able to consume more. They consume more, firms then get more profit, then those firms then will make more investment, and then so forth. So they were looking at the process, that flow process of percolation. And that was essentially, they called them dynamic impact multipliers, but that's exactly what they were doing. They were dynamic path coefficients. So yes, you can, in a completely non-parametric setting, what you could do is track, and you don't need differentiability either, by the way. I mean, you could basically end up with discrete methods, and but yes, Sewall Wright in a differentiable world can be characterized by doing the applications, repeated applications of the chain rule. How, X affects Y1, Y1 affects Y2, Y2 affects Y3, Y3 affects, Y4, and then maybe some recursive feature feeding back to Y1. So yes, that I think is a legitimate application of Wright's example, because Wright goes back to the 1920s, I think, at least the early 30s. So